Good morning, students. I am Gopal, head of the Department of Humanities and Science. Today, we have to discuss how to resolve the given rational fraction into partial fractions. Last class, we have to see the definition of polynomial and the degree of the polynomial and what is the rational fraction and the types of the rational fractions. So, we divide the rational fraction into two types. So, first one is proper fraction, second one is improper fraction. So, first we resolve the proper fractions into partial fractions. So, for example, the given rational fraction is like that, f of x by g of x. So, this is the numerator and this is the denominator. So, for example, we are taking one example here, x plus 1 by x plus 2 and x minus 3. Yeah, this is the rational fraction. So, now the degree of the numerator is 1 and the degree of the denominator is 2. For example, if we multiplying these two factors, we get this is x square minus 3x plus 2x minus 6 means finally we get x square minus x minus 6. Okay. So, means this is the denominator is also one of the polynomial and the degree is 2. So, means now we have to check it, the given rational fraction is proper or improper. This is proper. Why? Because numerator degree is 1 and denominator degree is 2. So, therefore, degree of f of x is less than degree of g of x. So, therefore, the given rational fraction is proper fraction. Now, here we have to check it g of x characteristics. So, means yes, we are taking the same example, x plus 1 by x plus 2, x minus 3. So, means the denominator first, for example, x square, this is becomes x square minus 3x plus 2x minus 6 means x square minus x minus 6. So, the denominator, for example, this type x square minus 6 minus x, and this denominator is decomposed into a linear factor. So, finally, we get this is equal to x minus 2, x plus 2 and x minus 3. Means if this kind of polynomial is given, first we decompose the denominator into linear factors. We get two linear factors here. So, based on the characteristics of g of x, we divided the methods. Okay. Now, this is the first method. In this method, the denominator contains non-repeated linear factors. So, denominator means this is the denominator of the given rational fractions. Now, it is contains non-repeated means this is x plus 2 one of the factor, x minus 3 another factor. So, means g of x is contains two linear factors, but they are non-repeated. Okay, repeated means we are taking one example, x plus 1 by x plus 2 into x plus 2. So, means g of x is contains the repeated factor. What is the repeated factor here? X plus 2 is the one linear factor and it is repeated twice. So, but in this method, the denominator contains non-repeated linear factor. Linear means, actually now this is not linear means, so this polynomial degree is 2. So, therefore, this is said to be second degree polynomial. X plus 4, for example, x plus 4 is given. So, this degree is 1. The first degree polynomial is said to be linear. So, this is linear and x minus 3, this is linear and x plus 4, this is also said to be linear. Clear? So, means the g of x, the denominator contains non-repeated linear factors. If the denominator having more than degree more than 1 means x square minus x plus minus 6, x cube plus 3x square plus 6x plus 9. For example, these kind of polynomials are contained, g of x contains, it is decomposing into linear factors. If possible, we have to written decompose this is into linear factors based on the g of x characteristics. This is the first method. What is the first method? The denominator contains non-repeated linear factors. So, g of x having these characteristics, so now we discuss how to we rewrite or resolve the given rational fraction into partial fractions. Yeah, now this is example. This is the given fraction. F of x we are taking as it is, but g of x we are taking this one. Example here, 2x plus 3 or 4x plus 5. For example, these are the two linear factors. If the given problem means rational fraction is contains two non-repeated linear factors. So therefore, we have to return a by capital A by ax plus b plus b by cx plus d. Okay, this is the standard format. If the given rational fraction in a given rational fraction g of x is contains two non-repeated linear factors, we have to return the given rational fraction into this form: a by capital A by ax plus b plus b by cx plus d. In case g of x is contains three non-repeated linear factors. For example, we have to return here. Yeah, now this is ex plus f. This is one more linear factor. This is c by ex plus f. Okay, so here the rational fraction is, in rational fraction g of x is contains three non-repeated linear factors. For example, g of x is contains n non-repeated linear factors. We have to return this example now: d by something and e by the linear factor, okay, and f by linear factor. Okay, now this is the process of rewrite the given rational fraction into this kind of expressions. So then we have to find out these constant values: a value, b value, c value, d value, e value, f value. So by using the both sides, either comparison method or substitution method. So we have to see in one example. Now we getting some idea of this kind of problems. The students, now we discuss this example: resolve x minus 4 by x minus 2, x minus 3 into partial fractions. Yeah, now we resolve this is into partial fraction. Now given that x minus 4 by x minus 2, x minus 3. Yes. So if any this kind of rational fraction is given, first we have to check that is proper or improper. Now in this method we have to discuss the proper fractions only. Yes, first check it is proper or improper. So what is f of x degree? 1. And what is the g of x degree? After multiplication of these two linear factors, it is becomes x square, means g of x degree is 2. So therefore degree of the numerator is less than degree of the denominator. So therefore the given rational fraction is proper fraction. And then check it, g of x characteristics. So means g of x is contains repeated factors or non-repeated linear factors. Okay, there is two types of characteristics are there. G of x contains non-repeated linear factors and repeated linear factors. Here g of x is contains two non-repeated linear factor. This is one of the linear factor and this is another linear factor. So if g of x is contains non-repeated linear factors, so it can be written as a by, so first linear factor x minus 2 plus, then we have to return b by x minus 3. Okay, now giving one number, this is equation 1. Okay, then we have to find out these values, capital A value and capital B value. So in order to find this A and B, first, so we have to return left hand side expression is as it is, x minus 4 by x minus 2, x minus 3, and we have to find out LCM of right hand side. What is the LCM here? X minus 2 and x minus 3. Then we have to return the numerator. Now A coefficient is x minus 3 and B coefficient is x minus 2. Right? So then we cancel these denominators. So finally we get x minus 4 equal to a of x minus 3 plus b of x minus 2, and we are giving this number, this is 2. Now we have to find out a value, capital A value, and a capital B value. In order to find capital A value, so we reduce this b coefficient into 0. So if we substitute x equal to 2, so b coefficient becomes to 0 means, so we eliminating this b, so we get a value. So in order to find a value, we have to substitute x equal to 2. So put x equal to 2 in equation 2, we get 2 minus 4 equal to a of 2 minus 3 plus b of 2 minus 2, means this becomes to 0, and this implies minus 2 equal to minus a. Here 2 minus 1 means a. This one cancels, so we get a equal to 2. Yeah, this is a value. And we have to find out b value. We substitute x equal to 3. Put x equal to 3 in equation 2. We get 3 minus 4 equal to a of 3 minus 3 plus b of 3 minus 2, and this implies minus 1 equal to, again now this a coefficient becomes to 0 means completely this is 0, and we get only b, implies b equal to minus 1. Yeah, we get a value, a equal to 2 and b equal to minus 1. We have to substitute this a value and b value in equation 1 means, so therefore equation 1 becomes x minus 4 by x minus 2, x minus 3 equal to, we have to substitute a value here, a equal to 2 by x minus 2 plus minus 1 by x minus 3. Yeah, now this is the process of resolving the given rational fractions into partial fractions. Now given this kind of expression can be expressed this kind of expressions. Now this is the process of finding or process of resolving the given rational fractions into partial fractions. Now students, now this is the second example. Resolve x minus 4 by x square minus 5x plus 6 into partial fractions. So now in this problem, g of x contains second degree polynomial. Yeah. Now we solve this problem. Now given that x minus 4 by x square minus 5x plus 6. So, but here this g of x is second degree polynomial. Now we decompose this one. Now since x square minus 5x plus x equating to 0 and this polynomial is equating to 0. So then we have to written this is minus 3x minus 2x plus 6. We have to find out the factors of this polynomial, and this implies in first two terms we are taking x common, x minus 3. In second two terms we are taking minus 2 common, x minus 3 equal to 0, and finally we get x minus 3, x minus 2 equal to 0. So means, so the given rational fraction now written in this form. Okay, so if this kind of denominator, so we having this kind of denominator, we have to written into this form. Okay, now we have to written the partial fraction. Yes, now this is equal to, and this g of x contains two non-repeated linear factors. So therefore a by x minus 3 plus b by x minus 2. We have to say that this is 1, and then we have to find out now these values. Okay, clear? And this implies x minus 4 by x minus 3, x minus 2, and we have to find out LCM of the right hand side, x minus 3, x minus 2, and we have to find out a coefficient, that is x minus 2, b coefficient x minus 3, and we cancel these two sides denominator and we get x minus 4 equal to a of x minus 2 plus b of x minus 3, and in order to find a value we have to substitute b equal to 3 here, put x equal to 3 here, x equal to 3, and we get 3 minus 4 equal to a of 3 minus 2 plus b of 3 minus 3, means this is completely becomes to 0, and this is implies minus 1 equal to a of 1 only, implies a equal to minus 1. This is the a value. Then in order to find b value, we have to put x equal to 2. Put x equal to 2 in equation 2, and we get 2 minus 4 equal to, this 2 minus 4 means minus 2 equal to, this is becomes to 0, and we get b value, b of minus 1. So means this minus cancel, so therefore b equal to 2. Yeah, we get a equal to minus 1 and b equal to 2. We have to substitute both these values in equation 1. So therefore the given rational fraction is x minus 4 by x square minus 5x plus 6 equal to minus 1 by x minus 3 plus 2 by x minus 2. Now this is the process of resolving the given rational fraction into partial fractions. Now dear students, now this is the assignment, resolve the followings into partial fraction. This is the first problem. Now in this problem, g of x is contains two non-repeated linear factors. Yeah, we have to resolve the given partial fractions into proper fraction the given rational fraction into proper partial fraction by using the same procedure. And here g of x is also contains two non-repeated linear factors. Here also g of x contains non-repeated linear factors. Yeah. Now solve these problems. In next class we have to see in case this g of x is contains repeated linear factors. Okay. If g of x is contains repeated linear factors, how to resolve the given rational fraction into partial fractions. Thank you very much.